The cell seen under a light microscope reveals the following: a cell wall made of cellulose and plasma membrane which encloses the protoplasm. Nucleus. It contains one or more dense bodies called nucleoli and a network of thread-like structures called chromatin. It bears hereditary characters called genes and regulates metabolic activities of the cell.
Cell, a structural unit. Cells are the structural and functional units of the body of all living organisms and also are known as the unit of life. Generally, we cannot see a cell with the naked eye, but some cells, such as a hen's egg, is big enough to be seen by the unaided eye. A microscope is an instrument used to see cells that are too small
Uniform and non-uniform motion. Activity. Examples. We can calculate the distance moved by a body in a given time if we know its velocity. From the equation, it can be seen that S is distance time graphs.
A glass filled with mixture of water and milk. Let us mix. We have a glass filled with solution of copper sulfate. A glass filled with mixture of water and milk. Let us take a torch, switch it on. The animation has been slowed to show a flow of light. The path of light travels through the copper sulfate solution. Hence we can trace the path of light visible inside mixture of milk and water. Scattering by particle effect is light scattering by particles in a colloid or in a very fine suspension. Now, let us do a small experiment. We have a glass filled with solution of copper sulfate. A glass filled with mixture of water and milk. Let us take a torch, switch it on. The animation has been slowed to show a flow of light. The path of light travels through the copper sulfate solution. Hence we can trace the path of light visible inside mixture of milk and water.
Body along the circumference of a circle. Example: motion of the earth around the sun is an example of circular motion. The third type of motion that we saw is a rotational motion. It is the motion of a body around a fixed axis which is passing through the object. This is important. The axis has to pass through the object. Example of rotational motion is a ceiling fan rotating along its axle. So you see that if I draw a hypothetical line called the axis of rotation, then it's passing through the fan. And the final type of motion is a periodic motion, which is the motion that repeats itself in equal intervals of time. Can you think of any example of this type of motion? Any object repeating its motion in equal intervals of time will be undergoing periodic motion. Assume an object is moving in circles and is covering each round every 3 seconds. Is it performing a periodic motion? Absolutely. Since it's repeating its motion along the same path every 3 seconds, it is undergoing periodic motion. But wait a moment. This object is moving along the circumference of a circle. So it is also undergoing circular motion. So what can you conclude from this example? We can say that an object can undergo more than one type of motion at the same time. Here are the few of the examples of motion in our everyday life. Go through them well and tell me what type of motion each one of them represents. And note that one example could also have more than one type of motion. The first one is clearly rectilinear motion. It's a car moving along a straight line. The second one is interesting. Most of us would have guessed rectilinear motion after seeing the word straight. Which type of motion are the wheels of an automobile performing? Are they undergoing rotational motion or rectilinear motion, or both? Since the automobile is moving in a straight line, its wheels are undergoing both rectilinear and rotational motion at the same time. What about the simple pendulum? We know that a simple pendulum performs to and fro motion. This to and fro motion repeats itself in equal intervals of time. So it's undergoing periodic motion. Now let me ask you a question. Suppose you want to travel to city B from city A. Which mode of transport will get you quicker to the destination? A bicycle or an aeroplane? Obviously.
Covalent bond. Covalent compounds. Positive ions. If an element has 1, 2 or 3 electrons in the outermost shell of its atoms, then it loses these electrons to achieve the inert gas electron arrangement of 8 valency electrons and forms positively charged ions or cations. Now, the metal atoms have usually 1, 2 or 3 electrons in the outermost shell, so properties of positive ions. Electron dot representation. Negative ions. Properties of negative ions. Electrovalent or ionic bond. Electrovalent compounds.